All right, we're back. We're just getting some 2D array experience under our belt today. And the way we're going to do that is by taking a look at a FRQ, a free response question. The focus of this is not necessarily on FRQs. It should be on 2D arrays. That being said, in practice, you would handwrite this code. Here, we're going to do it in IntelliJ because I get the advantage of not only, writing the code associated with it, also showing that it works, right? Because we can quickly make a driver and test our code, which you would not be able to do in a free response scenario. I'm going to skip some of the notes section here. As you can see, this one is a actual factual free response question from 2015. But I'm going to skip the notes where it talks about the Java Quick Reference, which is a reference sheet that you'll have on hand when doing these. There's some little bits about stuff not being null. You can assume that things are not null. That's a relatively new change, I believe. Right? Like, 2013 or so, they weren't doing that. Maybe 2014 is when they made that change. Not important. Let's get on to the question. It says, this question involves reasoning about one-dimensional and two-dimensional arrays of integers. You will write 3 static methods, all of which are a single enclosing class named diverse array, which is not shown. They don't give you the entire class. They just give you the methods, and you're just filling out the methods. The fact that it's a static class, basically a utility class, is only static methods, means that the rest of the class is not that important anyway. There's no instance variables, right, when we're talking about utility class. The first method returns the sum of the values of a one-dimensional array. The second method returns an array that represents the sums of the rows of a two-dimensional array. And the third method analyzes row sums. Okay. Part A. Write a static method arraySum that calculates and returns the sum of the entries in a specified one-dimensional array. The following example shows an array, ARR1, and the value returned by the call to arraySum. We have written this method half a dozen times easy. You're going to ultimately take in an array, sum up all the integers in it. Okay. If we jump down, we see this is the section where you would handwrite the code. We see a method header along with some JavaDoc returns the sum of the entries in the one-dimensional array ARR. Let's get started. I'm going to open up the IntelliJ. I'm going to create a new project. You can choose to handwrite this, right? All the FRQs are available online, or you can choose to code it along with me. What is this one called? Diverse array. I'm going to create that project, and we're going to ensure that we have a subfolder. I'm going to expand my project folder, right-click on the SRC, make a new Java class called diverse array. All right, we're going to go ahead and plug in this method header. All right, public static int arraySum, and it takes in an integer array called AR1. Keep in mind, this is just one part of it. All right, we've done this a bunch, but the other stuff, not so much. I'm going to go ahead and JavaDoc this thing with the same stuff they say here. Returns the sum of the entries in the one-dimensional array AR. Dimensional. Good stuff. All right, let's knock this one out real fast. I'm going to create some type of variable to store my sum before I start looping. I'm going to throw in a for loop. We'll also end up doing a for each loop. And when it comes to the FRQs, when it actually comes to the AP exam, it doesn't matter. It's up to you. If you don't like for each loops, don't do it. If for loops are your jam, go with that. Right here, I'm using a for loop to loop through the parameter AR1. And with each iteration, I'm just going to take the current element, that is AR at I, and I want to add it to my sum. And I don't want to lose the old value of sum. So sum is going to be what it currently is. Sum is going to become what it currently is plus the current value from the array. Now, all of you should know that we could shorthand assignment operator this thing, and we're going to loop through the entire array, which means after the loop is finished, I can return my sum. After the loop is finished, I have visited every element in the array. This should be it. I'm going to create a driver, and we'll go ahead and test this. And so notice that when it comes to FRQs, you're writing the method, right? The driver you don't see. You'll see examples. Right? They give us an example, but you don't actually create driver code. Here, since I am doing everything in IntelliJ instead of handwriting it, I can afford this time to kind of put together this array. So I'm going to create an integer array. I'm going to call it AR1 because that's what they call it in the example. And using an initializer list, 13273. 13273. Let's test it out. I want to call this method. It is static in the diverse array class. Again, you don't have to do this part. But in order for me to test it, I'm going to call it. It's diverse array. It's the name of the class. The name of the method is array sum. It needs an array. There's only one in this context. Array1. Okay, so this is going to return an integer value. It's just sitting here. Right? In order for me to actually see that, I'm going to need to print it off. And so I will right click in free space and tell it to run. Now, according to the example, we should get 16 from this. And we do. Okay, a quick look at a for each loop. Right, it's effectively the same thing, except I would say for each, we're looping through AR1, for each int, which I'll refer to as I. I don't like calling it I because I indicates index. And with a for each loop, it's not an index. I like either X, or I'll also accept E as a good one. But X tends to be my favorite. X is a specific number. I is an index. N is a number of numbers. Okay, so for each integer, which I'll refer to as X, in array1. Okay, using the for each loop here, it replaces the current element. The current element in this context is now X. I'm going to run it again. We'll see that we're getting our 16. And last thing I'll do is show you that we could get rid of the braces and still get ultimately the same result. Now, when it comes to FRQs, there's a lot of background stuff that I didn't really talk about. There's a lot of things that you can kind of omit. And as long as it's very clear what you're intending, you should be okay. For instance, you could, in theory, have multiple lines in this for loop. And as long as they are indented, it's pretty clear that they're supposed to be in the for loop. No reader's going to take off points for that. They shouldn't take off points for that. Let's look at part 2, part B. Write a static method row sums that calculates the sums of each of the rows in a given 2-dimensional array and returns these sums in a 1-dimensional array. The method has one parameter, a 2D array, called array2D of int values. The array is in row major order. That's a weird thing to say. Row major order is how you traverse the array. It's not a state of the array. That's okay. Array 2D at RC is the entry in row R, column C. The method returns a 1-dimensional array with one entry for each row of array 2D, such that each entry is the sum of the corresponding row in array 2D. There's a lot of words. I zoned out on most of them. Let's take a look at what's happening here. We have a 2D array. We ultimately are going to return a 1D array. If we look at a header, there is a header here, and we're actually going to see it on the next page as well. And we're going to go through the row, find the sum, and that becomes the first entry into the output array. Right? This thing is going to take in a 2D array. We're returning a 1D array, and that 1D array is the sum of the corresponding row. So for instance, this very first row in our example adds up to 16. This row adds up to 32. This row adds up to 28, and this row adds up to 20. That's the idea. If we hop down here, it says assume that array sum works as specified. I'm about to write row sums. What is array sum? Array sum is the method that we just wrote. So they are saying assume that it works, regardless of what you wrote in part A. And you have to use it in order to receive full credit. I can go ahead and tell you, you want to use it. This is going to make your life easy. Okay, it says complete the method row sums below. Blah, 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 blah. Let's get this thing in here. Public, static. We're going to return an int array. It's called a row sums, and it takes in a 2D array, which they are calling ARR2D. I'm going to javadoc. Returns a one-dimensional array in which entry at index k is the sum of the entries of row k of the two-dimensional array in array 2D. They're saying those things correspond. K, index k, and index k, or row k, returns a one-dimensional array in which the entry at index k is the sum of the entries of row k of the two-dimensional array ARR2D is what it's called here. Oh, I typoed this one earlier. Okay. I believe the example kind of tends to explain these things better than what the Javadoc does, but it is important to look at the Javadoc in case there are some key things, preconditions being one of them. No real preconditions here. We can assume this is not null. I guess that's a precondition. Interesting enough, they don't say anything about the length of it because the length really shouldn't matter. I'm getting off topic. All right. We ultimately need to return a 1D array. I'm going to create an integer array called sums. And it's going to be a new int array. We have to give it a length, right? I can't just say 0. You could get like real funky here and like create an array list and then later turn it into an integer array. That's more work than what you really need to know. So the question is, how long should this be? Well, we're going to be finding the sum of each row. So the length of this array should be the number of rows. How do I know how many rows are in my 2D array? Well, that is going to be AR2D.length. That's the number of rows. Right? The length of this is the number of rows. So that'll be also the length of sums. We're actually ready to start looping. Okay. Now, I know this is a 2D array, and so the first thought is just like, oh no, we need a for each loop. But not really. Because all we're doing is going through each row. I'm going to go to this row, I'm going to go to this row, and I'm going to go to this row. Part of the reason I picked this FRQ to kind of talk to you about is I always want you to keep in mind that a 2D array in Java is an array of arrays, right? This looks like a grid, this looks like a matrix, but you can also kind of visualize it as it's a 1D array, and this is the first element. This is the second element. This is the third element. Okay. Maybe another way to look at that is AR2D is a 2D array. Okay. AR2D at 0 is a 1D array. AR2D at 0, 0 is a single integer. 2D array, 1D array, single integer. Okay, why is that important? Well, if I loop through AR2D and I access the element at index I, for instance, this is a one-dimensional array, assuming I is an index, right? So if I come in here and I say for I I'm actually going to go ahead and change that to R. And as long as we loop through AR2D.length, this context is probably a little bit better. Right? This is a 2D array. This is a 1D array for sure. Right? And if I got the element at index 0, that's a single integer. Okay. So this is a one-dimensional array. It's the entire row. Keep in mind that a two-dimensional array in Java is an array of arrays. So each row is an array inside of, right? This array has a length of 4, has 4 rows. So there are 4 integer arrays. Okay, so I'm going to take this row. It's a single integer array. Why is that important? The method we wrote above takes in an integer array, and it tells me the sum of it. So it's actually super easy knowing that we have to use array sum because we want to. I want to take the entire row, send it to my array sum method. This is going to give me back a value. That's the value that I want to save into sums at that exact same spot. Okay, looking at this, we'll use this 2D array as an example. It has a length of 4 total rows. That means sums, it's going to have a length of 4, right? Sums is going to be, we'll leave it as a comment. Sums is going to look like that initially. We're going to loop through AR2D.length. You could also say sums.length in this context. They're actually the same value, right? 4. R starts off at 0. We're going to ask, is 0 less than 4? It is. We're going to pull the element from AR2D at index 0. Well, that's the entire first row. That's all these elements. We'll get it as a 1D array. I'm going to pass that 1D array to my sum method. That's going to compute the sum of it, give me back a value. I'm saving that value into sums at 0. Right? In our example, that first value should be 16. So it'll end up being a 16 after the first iteration. We would do an R++ afterwards. We would ask, is 1 less than 4? We would go get the second row at index 1. We would get the sum of that. That sum should be 32. We'll take that 32 and store it into sums at 1. And we'd go through basically every row doing that. So, despite this being a 2D array, one key concept here is recognizing that in Java, a 2D array is just an array of arrays. So we're going to go through each row, find the sums, throw them into our sums array. After we have gone through every row, I can safely return sums. Let's try this out. I'm going to flip back to my driver. And in order for me to try it out, I need this array. So I'm going to throw that over to my other monitor, and I'll create it. We're creating a 2D array called map1. Each row, and this is going to be a very good illustration of what I mean with about in Java, a 2D array is just an array of arrays. There's the outer array. Here's the inner array where the actual integers live and breathe. Right? That is my first row. I would like for easy tabbing. There's probably an IntelliJ wizard out there that knows exactly how to get this stuff to line up. And I kind of waver on how, oh, that's probably a pretty good way to represent it. I waver on how I want this thing to display. We could do it all in one line. Don't get me wrong. But I like to kind of make it look like what the 2D array is supposed to look like. Oh, yeah, this is better than when... This is better. And then my last one is 7, 6, 4, 2, 1. Something like that. Oh, I don't need this final comma. All right, so IntelliJ is nicely highlighting this opening brace, this closing brace. That is the outer array. There are 4 elements in this array. Those 4 elements are individual integer arrays, right? Mat1 is an array of integer arrays. Let's test out our method, right? I want to call diverse array dot row sums. I'm going to pass it my 2D array, which is called mat1. Now this is going to give me back an integer array, which I want to actually see. So I'm going to put it in a sout. And if I hover over this, IntelliJ is telling me implicit call to toString on array returned by, okay, what's the big deal? Well, if I run this, what does this method return? It returns an integer array. And as we've seen before, it's not the contents of the integer array. Again, this stuff here that's happening in the driver, you wouldn't need to write that on an FRQ. But for me to prove the point, I need to quickly see the contents. I'm going to cheat a little bit and use a pre-existing method coming out of the arrays class, which I need to import. You can import very quickly just by hovering over the red text and hit Alt-Enter, and then it imported arrays coming out of the util class. Okay, again, you don't need to do any of this because you're not writing drivers. You would just be writing the method. So we're going to go into diverse array and find the sum of all of the rows for this 2D array. That's going to come back as an integer array. I'll use arrays.toString to turn that into a string giving me the contents, and then we print that string showing the contents. And there it is. If I look back at my example, those are the numbers I should be getting. Okay, let's look at part C. A two-dimensional array is diverse if no 2 of its rows have entries that sum to be the same value. That is, all of the values that are in the sum, right? We just did the sum, the row sums. All of the values are unique. Here's an example. This is the same mat1 from the above example, right? We could see the row sums to know that. Those are all unique, which means if we asked, is mat1 diverse? Yes. Here's mat2. If you look at the sums for mat2, we have 14 occurring twice. Is it diverse? No. That's it. Write a static method is diverse that determines whether or not a given two-dimensional array is diverse. The method has one parameter, a two-dimensional array, blah, 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 blah. Again, I think the examples are really good, but some clarification could happen in the actual text. I'm going to hop to my diverse array. I'm going to turn this header. I'm going to replicate it, I should say. We are ultimately returning a Boolean value, and we want to know, is it diverse? Is what diverse? A 2D array, which they have labeled ARR2D. Returns true if all the rows in array 2D have different row sums, false otherwise. Again, these notes I think are super important. Assume that array sum and row sums work as specified. So even if you botch it, you can still assume that they work, regardless of what you wrote. Note that you have to use row sums to get full credit. That's okay. We want to do that. All right, so here we go. Returns true if all rows in AR2D have different row sums. I wish they would say unique. False otherwise. Okay. We have to use this method in order to get credit. And in fact, that's the first thing I want to do. I want to take this array, pass the whole thing up to this method. This method's going to do its thing, give us back a single one-dimensional array that should be all of the sums. I'm going to create int sums, int array sums, I should say. And that is going to be whatever integer array I get back by calling row sums, passing up this 2D array. So whenever we call this method, we'll take the 2D array. we're going to toss it to row sums. Row sums is going to calculate all of the sums for each row, which, by the way, we only have one statement, so we could get rid of these braces. Notice that that one is using array sum. Okay, we would get back a one-dimensional integer array with all of the sum values. If I used my mat1 example, we would get these values back. So now what I want to do is loop through these things and make sure that they are unique. The moment that I encounter values that are the same, we can stop there. So based on that, based on what I just said, this is actually probably a better example, because I can stop the moment that we find matching numbers. So I'm going to use these values. You know what? Let's just replicate a value. Let's just put 16 in this twice. We'll use this as an example. Let's say that we call row sums and we get back an integer array that looks like this. I now want to loop through this thing. Right. So I'm going to do for I. We'll start at, because this is a 1D array, I'm going to leave this as index I. We're going to start at index 0, right? It should be this first element. We'll say as long as I is less than sums.length, we'll do an I++. So initially I is 0, we're right here. What I want to do is then loop through basically the remaining part, just this section, and ask, is this 16? Is this 16? Is this 16? Okay. You need nested loops for this, which is another reason why I kind of like this problem. We don't do a lot of nested loops, but here you need nested loops. In theory, you could... No, you don't want to start at the very beginning. You want to start at the next index over. Right, so I'm going to create another loop here. I is taken. Notice IntelliJ defaults to J. I'm a big fan of using K because it looks distinctly different from I. That's all. When you're looking at stuff on the screen, the I and the J, they look distinct enough, right? I can easily tell a difference here. When you're handwriting code, that's a different story. I like K. I don't want to start K at index 0 because what we're about to ask is the element at index I, maybe it's time I brought in an index I. Let's bring this bad boy down. Right? We're going to have I, which is at index 0. We're going to have K. But I don't want to put K at I because I'm about to ask, is the element at index I equal to the element at index K? Well, yeah, it's the same element, right? I want to start K here. That should be in reference to I. Don't just start at 1. If you start at 1, right, in theory, if this was different, if this was a different value, in theory, I is going to be advancing. And if you start K at index 1 every single time, you're going to end up doing some backtracking. So you always want to basically start K 1 more than I. But we're still going through the same array, so we'll say sums.length. Okay, so I starts at index 0. That puts us here. We'll start K at index I+1. That puts us here. We're going to ask, are these elements the same? Right? If sums at I is equal to sums at K, then I have found matching elements. If I find matching elements, it's not diverse. We can stop right there. We can return false. Right? Keep in mind that the moment that you hit a return statement, you're going to exit the method. If we manage to go through everything and we never return false, we're going to return true. Okay, so let's actually step through this using the code that we have here. I starts at 0. K starts at I+1, so index 1 right here. We're going to ask, is sums at I, that's a 16, equal to sums at K? That's a 32. No, that's the end of the iteration. We would do a K++, putting us here. We're going to ask, is sums at I, right, we're right here, is sums at I equal to sums at K? It is. So we would return false. We would leave the method. Let's try a different value. Let's backtrack some. I'm resetting everything. I starts out at 0. K is going to be I plus 1. We're going to ask, is sums at I, that's a 16, equal to sums at K, that's a 32? No. We would skip over this body. We would do a K plus plus. We're now on this element. K is still in bounds. We would ask, is sums at I, that's a 16, equal to sums at K, that's a 10? No. We'd skip over this body. We would do a K plus plus. K is now here. We would ask, is sums at I equal to sums at K? No. We would do a K plus plus. K would be here. We would ask, is it still in bounds? It is not. So that would be the end of the inner loop. We would come up, do an I plus plus. K technically doesn't exist anymore. However, we would check to see, is I still in bounds? It is. We would create K. It's I plus 1. That puts it here. We would ask, is sums at I, 32, equal to sums at K? That's a 10. No, those aren't the same. So we'd skip over this, do a K plus plus. That puts us here. We're still in bounds. We would ask, is 32 equal to 20? It is not. K plus plus, we're out of bounds. That's the end of the inner loop. We would do an I plus plus. K technically doesn't exist anymore. We would ask, is I still in bounds? Yep. We would create K. It's going to be I plus 1. That's this element here. We would ask, are those the same? They're not. We would do a K plus plus. That puts us out of bounds. We would do an I plus plus, which would put us there. We would create K and then ask, is it in bounds before we proceed? And we would end up stopping there. So we would exit all of our loops with the only thing left being return true. This would be a diverse array. Let's use their examples to demonstrate this. I've already got mat 1. We can go ahead and test it. And I'll create mat 2. Right? So there's mat 1. I want to know, is that diverse? I'm going to call diverse array is diverse, passing in mat 1. True. It's a diverse one. It's gonna be a lot of work to create mat 2. I'll do it. Okay. To the other screen for you. It is a 2D array. Each element in this 2D array is an array. An array of integers. I kind of like this. I kind of like the opening and closing there. Good call, IntelliJ. What happens if I just hit enter on this bad boy? Oh, yeah, let's roll with that. All right, I've got mat 2. It's the values that are shown in the mat 2 example. All right, these are the sums here. Why don't I go ahead and print off the sums? I'm doing this kind of as a quick way to check, do I even have the right values, right? I just punched in like 20 values. If one of these is off by 1, it'll quickly tell me. Right, 14, 35, 36, 14. Nailed it. First try. This guy's a pro. Let's do an S out on diverse array is diverse, passing in mat 2. And the answer here is false. That's actually the end of it, right? There's space for us to write our answer, and then it would go into problem 2. Effectively, this is kind of a contains method, right? Just this section here. A little bit better because you don't want to check the whole array, right? You would get definite it's not diverse if you check the whole array. If I want to know, does 16 occur in the array? I want to get a yeah every single time. I don't want to know, does 16 occur in the whole array? I just want to know, does it show up anywhere in the remaining portion of the array? Does 32 show up in the remaining portion of the array? Does 10 show up in the remaining portion of the array? But that's going to do it for our FRQ from 2015. I'll see you in the next one.